Alright guys, today's goal. The learner will understand exponential and logistic modeling. So you'll need calculators. Alright, convert the percent to a decimal form or decimal into a percent. Okay, so let's see. 16%. That would be 0.16. Move that forward. 5%. Show how to increase 25 by 8% using single multiplication. Well, that's 100% plus 8% of it. Solve this algebraically. So you would get b squared equals 36 square root b equals plus or minus 6. Solve this numerically, so 7.872 divided by 123 take the cube root of that. B equals 0.4. Let's see if we're right. There we go. What you'll learn about constant percentage rate and exponential functions, exponential growth, and decay models, using regression to model the population, other logistic models. And why? Exponential functions model many types of unrestricted growth. Logistic functions model restricted growth, including the spread of disease and the spread of rumors. Suppose that the population is changing at a constant percentage rate, R, where R is the percent rate of change expressed in decimal form. Where R is the percent of rate of change expressed in decimal form, then the population follows this pattern. So this is the pattern that you can look at here. P naught's the initial population, and then you take the initial population times 1 plus R, and then if it's been 2, 1 plus R squared, R third. So here, this is the standard form for constant percent rate of change. Okay? So let's look how we do this. So if population P is changing at a constant percent rate of R each year, then P of T equals P naught times the quantity 1 plus R to the T, where T is time in years. Or it could be seconds, it could be hours, it just depends on the problem, but yeah. Okay? Tell whether the population model, P of T equals 786,543 times 1.021 is exponential growth function or exponential decay. And find the constant percent rate of change. So I look. Couldn't I do this? So I can identify my initial population is this. If I multiply that by 1.021, is it going to get bigger or smaller? It's going to get bigger. So it's growth. It's exponential growth. And what's the rate of change? Well, inside the parentheses is 1 plus R. What does that equal? So there's the rate, and if we convert it to a percent, the rate would be 2.1%. There we go. So here's the thing. This number right here, if it's bigger than 1, it's growth, less than 1, it's decay. Determine the exponential function with an initial value of 10, increasing at a rate of 5% per year. Okay, so P of T equals 10, 1 plus 0.05 to the t. P of t equals 10, 1.05 to the t. All I did was fill in the initial amount and the growth rate. And it said increasing, so I added that rate. If it says decreasing, you subtract it. Let's see. There we go. Suppose a culture of 200 bacteria is put into a petri dish, and the culture doubles every hour. Predict the number of bacteria that will be in 350,000. Okay, so let's see. If we set this up, the initial is 200. The growth rate doubles, which means it's 100%. And 100% converted to a decimal is 1. So you'd get P of t equals 200 times 2 to the t. Now we can substitute in 350,000 equals 200 times 2 to the t. Divide by 200, you get 2 to the t equals 1750. Now what you need to do, so the inverse operation of exponential is log. So now what you need to do is use your calculator and just put it in there. And, well, what you could do is this. Subtract the 17. And then at this point, use your calculator to approximate the distance, or the time needed. And then graph that, so subtract 0, or subtract 1750. Graph it and find the 0, and you get x equals 10.77. So 77, it's about 10 hours, 45 minutes, because 77 is almost 3/4 of an hour. Okay? Suppose, oh, there we go, 46 minutes, I guess. So I should have done point, yeah, 0.77 times 60 is 46.2, so 46 minutes. Okay? Use the data 1900 to 2000 and exponential regression to predict the U.S. population for 2003. So I would say let 1900 equal 0. Do the years since 1900 and use that for the population. And then do that in your calculator, and we'll see what we get. If you're unsure, ask about it in class, please. So if we do that, that's the equation you should come up with. If you didn't, ask in class. Okay? Maximum sustainable population. Exponential growth is unrestricted, but population growth often is not. For many populations, the growth begins exponentially, but eventually slows and approaches a limit to growth called the maximum sustainable population. Cities build up quick and then level off. A high school has 1,500 students. 5 students start a rumor, which spreads logistically, so that S of t equals, there's the equation. Model the number of students who have heard the rumor by the end of t days, where t is 0, is the day the rumor begins. So how many students have heard the rumor of end of day 0? Well, plug it in. and negative 0.9 times 0 is 0. What's anything to 0 powers? 1. Oh, I forgot the E in there. So e to the 0 power is 1 times 29 is 29, so I get 1500 divided by 30, so 500, I think. Oh, 50. That seemed too big. So 50 students by the end of day 0. So how long does it take for 1,000 students to hear the rumor? So you say 1,000 equals 1,500 divided by 1 plus 29 e to the negative 0.9t. So try to bring this problem in completed, and we will see you tomorrow.